Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. This is Saadat Ali, SS Physics at DPS and Intercollege Sahiwal. I welcome you to our online channel. I am here to teach you physics. So let's start our today's topic.
Bismillahirrahmanirrahim. Students, our today's topic is numerical problems 3.6 to 3.10 from chapter number 3, Dynamics. Before starting our today's lesson, we need to recall some important formulae from the chapter that will be quite helpful in solving these numericals. First of all, the formula for tension and acceleration in a string for a vertical system. Students, we have read in the chapter that when two masses, that is M1 and M2, are hanging over a frictionless pulley in a vertical system, their acceleration can be found using the formula A is equal to M1 minus M2 over M1 plus M2 into G. Here M1 and M2 are the masses of the objects A and B respectively, and G is the gravitational acceleration. If we want to calculate the tension in the string, then we can use the formula T is equal to 2 M1 M2 over M1 plus M2 into G. Again, we have read in the topic where two masses are attached to the frictionless pulley when one mass is hanging vertically and the other mass is placed on the table. In that case, we can find the tension and acceleration in a string by the following formulae. Acceleration can be found using the formula A is equal to M1 over M1 plus M2 into G, and tension in the string can be found by the formula T is equal to M1 M2 over M1 plus M2 into G. Another important topic, that is force and momentum, or Newton's second law of motion in terms of momentum. First of all, we come towards the statement of the topic, that is, when a net force acts on a body, it produces an acceleration in the body which will be equal to the rate of change of momentum of the body. Its mathematical form is given as Pf minus Pi over T is equal to M into A. Here Pf is the final momentum, Pi is the initial momentum, T is the time taken, and m and a are the mass and acceleration of the object. Dear students, as we know that by Newton's second law of motion, F is equal to m into a. So this F is equal to m into a can be replaced in this equation, and we get the above formula as Pf minus Pi over T is equal to F. Here m into a is replaced by force. Coming on to our next formula, that is relation between coefficient of friction and force of limiting friction. Dear students, in the topic of friction, we have read in detail the relationship between the coefficient of friction, that is mentioned by mu, force of limiting friction, that is mentioned by Fs, and the normal reaction, capital R. We know that the formula is given as mu is equal to Fs over R, and by rearranging we get formula Fs is equal to mu into R. Say this is equation A. As we know that this normal reaction R is equal to weight of the object, and the expression for weight is W is equal to m into g. So replacing this value of R, that is normal reaction, in the above equation, we get Fs is equal to mu mg. Now coming on to the next formula, that is centripetal force. We know that the formula for the centripetal acceleration is given as AC is equal to V square over R. Here AC represents the centripetal acceleration, V represents the velocity, and R is the radius of the circle. Say this is equation A. We know that by Newton's second law of motion, F is equal to m into A. In this case of centripetal force, Fc is equal to MAC, where Fc represents the centripetal force, m is the mass of the object, and AC represents the centripetal acceleration. Say this is equation B. So putting the value of centripetal acceleration from equation A to equation B, we get Fc is equal to mv square over R. This is the expression for the centripetal force. Now let's move on to our today's topic, that is numerical problem number 3.6. Two masses 52 kg and 48 kg are attached to the ends of a string that passes over a frictionless pulley. find the tension in the string and acceleration in the bodies when both masses are moving vertically. Here in this statement, the given data is M1, that is 52 kg, and M2 is equal to 48 kg. Here the gravitational acceleration is 10 meter per second square. We need to find tension in the string and acceleration of the objects. First of all, we find the tension in the string. For that purpose, we know the formula for the tension in the string is T is equal to 2 M1 M2 over M1 plus M2 into G. Now putting the values in this equation, we get T is equal to 2 multiplied by 52, that is the value of M1, multiplied by 48, that is the value of M2, divided by 52 plus 48, multiplied by 10 meter per second square, which is the value of gravitational acceleration. By solving this, we get 499.2 Newton, which is approximately equal to 500 Newton. Now, for the value of acceleration, we can use the formula as A is equal to M1 minus M2 over M1 plus M2 into G. Putting the values in the above equation, we get 52 minus 48 divided by 52 plus 48 multiplied by 10. By solving this, we get 4 multiplied by 10 divided by 100 gives us 40 divided by 100. By solving this, we can get the value of acceleration as 0.4 meter per second square, and that is the answer of the question. Moving on to problem number 3.7. Two masses 26 kg and 24 kg are attached to the ends of the string, which passes over a frictionless pulley. 26 kg is laying over a smooth horizontal table. 24 kg mass is moving vertically downwards. Find the tension in the string and acceleration in the bodies. Dear students, this is the case when two objects were attached to the ends of the string passing over a frictionless pulley. That was the horizontal case. Given data, M1 is equal to 24 kg, M2 is equal to 26 kg, and the value of gravitational acceleration is 10 meter per second square. We need to find tension in the string, and for that purpose using the formula T is equal to M1 M2 over M1 plus M2 into G. Putting the values in above equation, we get 24 multiplied by 26 divided by 24 plus 26 multiplied by 10 gives us 6240 divided by 50. By solving this, we get T is equal to 124.8, which is approximately equal to 125 Newton. And this is the value of tension in the string. Now, we need to find the acceleration of the objects. For that purpose, using the formula A is equal to M1 over M1 plus M2 into G. Putting the values in this equation, we get 24 divided by 24 plus 6 multiplied by 10 gives us 240 divided by 50. By solving this, we can obtain the value of acceleration as A is equal to 4.8 meter per second square. That is the value of acceleration of the objects. Now, problem number 3.8. How much time is required to change 22 Newton second momentum by a force of 20 Newton? Students, let me tell you, this is a very important question and a very simple question as well. We know that change in momentum, that is Pf minus Pi, is given as 22 Newton second, and force is given as 20 Newton. We need to find the time that is required to change this momentum by this force. We have read the formula of Newton's second law of motion in terms of momentum, that was F is equal to Pf minus Pi divided by T. Here F is the force, Pf is the final momentum, Pi is the initial momentum, and small t, it represents the time taken. So, by rearranging the previous equation, we can find the value of time as T is equal to Pf minus Pi over F. Putting the values in this equation, we get T is equal to 22 divided by 20 gives us the value of time as 1.1 second, and that is the answer of this question. Now, moving on to our next numerical problem, that is 3.9. How much is the force of friction between a wooden block of mass 5 kg and the horizontal marble floor where the coefficient of friction between wood and the marble is 0.6. The given data is mass of the object, that is 5 kg, the frictional coefficient 0.6 and the gravitational acceleration, that is 10 meter per second square. We need to find the force of friction. For this purpose, using the formula for the force of limiting friction, Fs is equal to mu into R. We know that R is the normal reaction and its value is obtained by R is equal to W, that is weight of the object, is equal to m into g. So putting the values in this equation, we get Fs is equal to mu mg, where mu is the frictional coefficient, m is the mass of the object and g is the gravitational acceleration. Gives us F is equal to 0.6, that is the value of frictional coefficient, 5, that is the value of mass, and 10, that is the value of gravitational acceleration. By multiplying these, we get F is equal to 30 Newton. And that is the answer of this question. Moving on to our last numerical problem, that is 3.10. How much centripetal force is needed to make a body of mass 0.5 kg to move in a circle of radius 50 centimeter with a speed 3 meter per second? Dear students, this is also a very important numerical, and this is a very simple numerical. We can use the formula of centripetal force in this numerical to find the answer. Given data is mass of the object, that is 0.5 kg, speed v is equal to 3 meter per second, and radius of the circle, that is given in centimeter, its value is 50 centimeter. We know that centimeter is not the standard unit of length, so we need to convert it into the standard unit, that is meter. For that purpose, we divide 50 by 100, gives us the value of radius as 0.5 meter. We need to find the centripetal force. For that purpose, using the formula of centripetal force, Fc is equal to mv square over r. Here m is 0.5, speed is 3 meter per second, and the value of radius is 0.5. These two terms, 0.5 and 0.5, they will be cancelled out with each other, and we are left with the square of 3. So we get the value of centripetal force as 9 Newton. That is, the square of 3 gives us 9 Newton, which is the answer of this question. Now students, it was our today's topic, that is the numericals from 3.6 to 3.10. It's time for our assignment that are very simple numericals that you can solve with the help of our today's lesson. First of all, question number 1. How much time is required to change 100 Newton second momentum by a force of 50 Newton? Students, you can use the formula of Newton's second law of motion in terms of momentum or the force of momentum in this question, and you will feel quite easy to solve this numerical. Our next question: how much will be the force of friction between a wooden block of 10 kg mass and a concrete floor? The value of coefficient of friction between wood and concrete is 0.62. Students, this is a simple question. You can use the formula of force of limiting friction in this numerical and find the answer of this question. Moving on to our next question. How much centripetal force is needed to make a body of mass 5 kg to move in a circle of radius 10 centimeter with a speed of 5 meter per second? Students, you can use the formula of centripetal force that is being utilized in our numerical 3.10. This question is quite identical to that numerical, and I hope you will feel quite comfortable while solving these questions with the help of our today's lesson. That's all for today. Thank you very much.